All right then, so why Zend Expressive? And I've got a question for you first of all, is why have you picked those frameworks? What is it that that framework does that makes your life easier when you're building APIs?
Supporting documentation.
Supporting documentation, okay, that is an important one.
Inherited decision.
Inherited decision.
Inherited decision.
Okay.
Told to.
All right.
Inherited decision.
I think really easy to develop. Easy to get something that you need quickly.
Easy to develop quickly. Okay. Well, my motivations are a little different. Looking over my career, I tend to build apps that have a long shelf life. Code can be in production that I've written 4 or 5 years quite easily. But I don't stay on a project for 4 or 5 years. I tend to move on and hand it off to other people. Now, when you've got an application that's lived that long, after 5 years, it looks very different to where it started from, because nothing stays static. New requirements come in, old requirements disappear, legislation changes, and so the app is constantly being changed by people. You don't deploy it once and then 5 years later it's still there being a useful app. That just doesn't happen in this day and age. It's fine for static websites, but for apps that are doing APIs, the APIs are constantly having to evolve and be updated. So the first thing I want to do is I want to isolate that framework. And to show you what I mean, I want to show you what happens when framework code executes. So I've put together a diagram showing the execution flow at a very high level when you've got an API that's driven by a framework of some sort. And there's always a bootstrap stage. The framework has to load its own code, it has to load its config files, and has to understand the context it's executing within. Then it has to look at the incoming request and figure out where the hell it's supposed to go. It has to match it to the routes that you have defined. Then there's some sort of dispatcher whose job it is to send that request to the correct piece of code that you have written. And often routing and dispatching are handled by the same component, the same lump of code internally. But conceptually, they're 2 separate pieces of work. Then it's handed over to your code. Now, this might be called a controller, it might be called an action, it might be called a handler. Other frameworks have their own preference terms, but it's essentially the same thing. This is an adapter. Its job is to adapt your business logic to the framework that is handling incoming requests and outgoing responses. Then you disappear off into the features, the business logic, the thing you're actually getting paid to build and ship at the end of the day. And that will generate some response data of some kind. It goes back to the controller, and the controller will prepare that in some sort of response that the framework's expecting. Then the framework will turn that into a HTTP response and put it on the wire back to Apache or Nginx or whatever you're running your app behind. That's the rough, at a high level, that's the rough execution model. And it's the same regardless of what framework you're using and what technology. Different frameworks may use different names. They may have extra steps in there, but it's roughly the same process throughout. Now, if we look at the responsibilities, this left-hand column is all framework code. This is one of the reasons we all use frameworks, because we don't want to be writing bootstrap stuff all the time. We don't be writing our own routers and handling our own dispatch. And we don't want to be doing all the formatting to send the response out on the wire. That is perfectly suited to a framework. So we want the framework to do that all the time. Then we've got this middle bit, which is, as I said before, is to adapt our business logic to whatever framework we're running against. And I'm going to call that glue code. And then finally, we've actually got the business logic itself. So that's what happens when an app executes, and that's how the responsibility is divided up. And we're going to be coming back to this model over and over throughout this talk. Now, the thing for me, because this app lives so long, it lives longer than frameworks do. In 3 years, how many Laravel releases have there been? How many upgrades have they had to do? Yeah. It's going to be the same with .NET Core, especially as it's a relatively new framework. It's still stabilizing and maturing. Symfony's had a big release in the last 12 months, I believe, and probably had a couple of point releases before that. So one of the things with long-lived code is framework upgrades are inevitable. You have to try and plan them in. But what I want to be able to do is I want to be able to manage that cost. I want to take that left-hand column and I want to be able to upgrade it without touching any of this other code. This glue code already works. I don't want to touch it. I don't want to spend time having to adapt it and retest it, and maybe even having to adapt my tests as well. And certainly not my business logic. I don't want to touch that at all just because of a framework upgrade. Not once. That code works. It's making money for my client or for me as a business. Don't want to touch it. And if I've got to go in there and touch it just because the framework's been upgraded, I'm wasting money, wasting time. I don't want to spend that time. See, I've seen a lot of framework upgrades over the years. They're a lot better than they used to be. They used to be really destructive. But they're very expensive. And I don't know about you, but I can't, if I've got to do a framework upgrade, I can't estimate how long that's going to be. Yeah? Half a day, a week. The more code it touches, the harder that estimate is to get accurate. And you don't know what problems you're going to find as you go through that process. And of course, it's not just expensive in that sort of time. Sometimes you've got to do a framework upgrade because it's shipped an urgent security fix. And you urgently need that security fix to keep your site safe. You can't always rely on security fixes being backported 100%, especially if you've skipped a few upgrades because you felt you didn't need anything new, and all of a sudden you're facing a bigger upgrade. So I want to isolate the framework. I want to put it in a box and keep it there, and keep it away from the rest of my code. And this has some consequences. First thing is, that glue code can't use the framework at all. Because if it uses the framework, I'm going to be forced to make changes to it when I upgrade my framework. So it's got to be independent of the framework. And that business logic on the right-hand side, that column, that can't use the framework either. It has also got to be independent because, again, otherwise I have the problem that I have to spend time upgrading that when I do a framework upgrade. So I want a framework that's a very light touch that just does that left-hand side. So these design constraints, though, they bring in other benefits which we're going to touch throughout this talk. And the first one is actually being able to reuse this glue code a bit more. Now, where am I coming from with this? I run my own business. I build and ship apps to clients. So it's important to me that as much time as possible goes on the things that are unique to that client. I don't want to be reinventing the wheel all the time. I mean, that's one of the reasons we use frameworks in the first place, is to try and avoid that. So if we look at our model, I want to spend all my time over here in the business logic. Glue code's inevitable as we add new sections of business logic, but I want to spend as much time as possible over on that right-hand side. How many of you have heard of PSR 7 and PSR 15? Danny has. So one of the things I like about Zend Expressive is they are very keen to be as supportive of these kind of standards as possible. And these two standards together give me interfaces to program against and consume for dealing with messages and something called middleware, which I'm going to introduce in a moment, which helps me isolate the framework. I'm not depending on a Zend class, I'm depending on a PSR interface, which helps me with that isolation. So if we look at our execution model and we introduce middleware, it now looks like this. But one of the reasons I like Zend Expressive is middleware is baked into the core of its design. This left-hand side is actually effectively a middleware pipeline that then calls another middleware pipeline. And it means the execution path changes and looks like this. You've still got your bootstrap, you've still got your routing, you've still got your dispatch. But now what happens, instead of calling the controller's at the end of a pipeline where you can put as many pieces of middleware in as you want. And execution just flows down, and there's nothing stopping any of these middleware calling into the business logic as and when required. They're not running in any sort of sandbox or anything like that. But it runs down all the way down to the controller as before, which then obviously uses the business logic to prepare the actual API response. Now the other thing here is this is a stack. So as it unwinds, the middleware gets to see every single response that comes back as well, which means it can look at that response and take action if necessary based on that response. So you get two bites of the cherry, if you like, with this approach. It does mean you get very deep stacks if you really load up your middleware. There's no real way around that, I'm afraid. And it comes all the way back to the dispatch and out to the responses before. Now, the nice thing about middleware built to the PSR standards is it's a completely isolated unit. It doesn't know anything about the pipeline it's running within. It's not even aware that it's running in a pipeline. As far as it's concerned, it's got a request coming in. It's got something to pass that request onto once it's done whatever it's there to do. And it will get a response back from whatever it's called, which it can then modify before sending the response back as an output. It's a very simple model, but it's nice and isolated as well, which means you can move these things around in your stack to suit. You can move them from one stack to another, from one project to another to suit as well, which is really nice. So it gives me that reuse I want. It encourages me down that platform, down that approach. And once you get used to it, I wouldn't want to go back to anything else. I really wouldn't. The discipline really helps. My third motive is change isolation, which is really where I'm going with all this other stuff. Anyone who's worked in any sort of enterprise company, an ITIL-based organisation, if you ship a release to prod and things get worse in production, the first question the service manager will ask is, what was in that release? What did you change? Because when you ship changes to prod, that's what causes bugs. I know it seems a really silly thing, but how many of you have shipped code and then something broke somewhere else that you weren't expecting? Yeah? Because you don't have the right level of isolation. Now, I often work on large systems. One system I've built in the last few years handles millions of pounds of transactions. And I'm not there to maintain it anymore, so it was important to make sure it was set up in a way that other developers could come in, they could add new features without breaking what was already there. Part of that is about making sure the code's isolated as well. So if we look at our execution model again, that middleware is an isolated piece of code. It's a standalone unit that is just plugged into a pipeline. The business logic can be built as standalone pieces of code that are then just being called from somewhere else. And changes to one piece of business logic, if it's done right, shouldn't affect any changes, shouldn't affect the functionality, of any other pieces of functionality. So, dry code's all the rage. And I'm well aware that certain frameworks and certain high-profile developers love to talk about how dry their stuff is. Problem is, if you dry your code out too much, it gets brittle. You don't want it absolutely bone dry. I absolutely agree, your low-level libraries should be dry because they are they're primitives, they're doing very simple things, just like all the PHP functions that ship with PHP do, and all the PHP extensions. Once you start to get into business logic and you start to get into glue code, you don't want it very dry. Sometimes the right thing to do is to actually cut and paste code rather than move it all into shared code. The reason for that is over time requirements diverge, and you end up, if you've got everything totally shared code and you go and edit that shared code, but it's actually business logic or it's providing a supporting service to one of these things you thought was isolated, you could end up changing something you didn't expect. Code diverges over time, so don't make everything too dry. And Zend Expressive for me really helps encourage this approach. And the final one is actually being able to understand what the bloody hell's going on. Sometimes I'm called in to rescue projects. And the first thing to do with that is to understand what is actually happening. Because one of the reasons projects go wrong is bad requirements, but another reason projects go wrong is because the code isn't doing what the developer believes it does. That is very common. The number of times I've had to sit a developer down and explain to them, your code is not doing what you've told me it does at all, not even close. So it's important to be able to reason about it. Now, I mentioned I've been doing this for a long time, so PHP is not the first programming language I've used professionally by any means. The reason people like me came to PHP after the .com boom is because PHP execution model is unique. I don't know if you're aware of that, but no other language encourages you to build request reply services in this way. They're all app servers of one form or another. They're all stateful engines that continue to run between requests. PHP doesn't. After your request is finished, it tears everything down and starts from a blank slate every time. And this creates conditions that help with what's called deterministic code. And deterministic code tends to be more reliable, tends to break less, because it's consuming less side effects. So that's the strength of PHP. Now, although the language is designed that way, there's nothing stopping you in user space undermining that feature, that guarantee. Aspect-oriented programming or any other event-driven system, facades that completely hide the actual code you're calling and lots of magic so you don't actually know what's being called. Event hooks, another one, or filters hooks, for example. All of these add up to make it impossible at a certain scale to be able to trace through the code and understand what's happening just by reading it. At that point, you have to dig out Xdebug, free up several gig of disk space on your machine, run a full trace through, and then go through it and see where the code's actually gone at that point. I want to be able to reason about the code by reading it, not by having to execute it. Because all these things make it harder for a developer to understand what the code actually does. Much harder. It's a lot more to keep in your head, and it's easy to miss things. But if we look at our execution model again, that is absolutely traceable. You can follow that through. You can work all the way through it and follow it through and understand exactly how it works and exactly where it's going. Everything's traceable without having to execute it. And the other thing is everything in there, we can take it out and test it in isolation if we need to. We don't have to run the whole thing in order to do any testing, which is really handy as well. So those are the reasons I have gone for Zend Expressive. Those are my motives for what I am looking for and why. It's all to do with making sure over the lifetime of that code, I don't end up bloody hating it. And the person I hand it to doesn't end up hating it either. One can hope. One can hope. So when I was looking around for a framework for this, Zend Expressive was the one that stood out to me for doing all of this. Very much so. But that doesn't mean what's important to me with my code base is important to you. If you work in an agency, for example, where you're creating disposable, throwaway little microsites for something, or you're throwing up quick and dirty internal services that aren't meant to live for a long period of time, your requirements may be very different. And there's nothing wrong with that. I'm not trying to say this is what everyone should be doing by any means. I'm just showing you a little glimpse into my little mad world.